D? Four.
Number 4.
I chose A, so it's 4.
Yeah.
D.
It's rounding up.
Okay.
Okay. Yeah.
We need one more.
So the answer is D. Okay. What is round, by the way?
The nearest whole number.
Yes, the nearest whole number. If you, yeah, that's right. But round itself in Python, what do we call round? It's a function. And how do we know it's a function?
Keyword.
Huh?
It's built in the Python.
Yes, but we don't see that when we look at that line, round 2.52. There's something that you see that tells you that it's a function.
Parentheses.
The parentheses.
The parentheses.
The parentheses. Sometimes there will be nothing between the parentheses. So those are functions that do not take any input, any values. And this is a function that expects an input, which is the number that you want to round. So you give it to it as input, and it then rounds it to the nearest whole number.
Gotcha.
Okay. Number 2, if you enter 1, 2, 3 in 3 separate lines when you run this program, I said a really easy quiz today. What will be displayed? That was because I was in such a rush. Didn't get the time to find the hard ones. So you're lucky. Just for today. Print. So this is the code. Print, enter 3 numbers, and then we have these 3 lines actually, and that's followed by 2 more lines. So that's the code. So what's going on here? We're finding the average of those 3 numbers, right? Now, so this line is simply prompting the user, just printing this message, enter 3 numbers, and then the input function, again, it's a function because it has the parentheses after it. The input function expects the user to type something into the keyboard, and so that's the call to the input function. And you can see that the word int, okay, itself is the name of a function because it also is followed by that open parenthesis and the closed parenthesis. And inside those, inside that pair of parentheses, I mean that one and that one, we have as a value the input function. So let's not worry too much about that. The point here is we are looking at 2 functions here, the input function and the int function. What the int function does is it
Why not we just put eval?
Why don't you just put eval?
okay, yeah, good question. Eval and input do exactly the same thing. That is, they get an input through the keyboard from the user. So why are we not using eval? Because eval can create problems. And I'll tell you about that later. So it's better that you use input because you achieve the same result, eval and input. Okay?
Okay.
I think in the textbook they've used eval a lot. I tend to avoid eval because firstly we don't really need it. We can get the same result just using input, which is much more easier to follow anyway. Input inputs the value, and eval can be problematic. It can cause other issues in your program. So we're getting 3 inputs, and the inputs are ending up where?
Yeah.
Number 1, number 2, and number 3. Now this is very important. The concept of using this, which is what is it called? It's an operator.
Yeah.
It's an equal sign, yes, that's how we've known it all our lives. But now, in the context of programming, it has a name. It does something specific. It does not just tell us, in fact, it does not tell us that whatever appears to the left is equal to whatever appears to the right. It's not for that.
It assigns a value.
It assigns a value. So it's called the assignment operator.
Ah.
Okay? Equal in programming in Python and Java is actually this. Right? If you want to write x equals y, that's how you would write it.
equal signs.
If you write
instead of
x
this one.
It was 2 equal signs.
Yeah.
and then y with just this in between, it means we are assigning y to x. Alright? X may have a value which is quite different from y, but then if we say this, with that assignment operator in between, the value of y, which is on the right hand side, gets stored into x.
Ah.
Okay, that's why it's called assignment, because the value of y gets assigned to x. And we do a lot of assignment in programs. Okay, so number 1 gets assigned whatever we are getting on the right hand side, and we are of course getting it as a number typed in by the user. So that number gets assigned to number 1, and then same thing happens for the second time, except that the second number gets assigned to a different variable, number 2. And third time, another number, which is 3, gets assigned to a third variable called number 3.
Oh,
so
number
now
3.
we have 3 variables.
Ah.
3 variables. Number 1, number 2, and number 3. And in memory, that is in our RAM, we have somewhere the value 1 stored. Okay, so it's typical to just show it like that. And then somewhere in memory we have the value 2 stored, and somewhere in memory we may have the value 3 stored. We do actually 3. Okay. So this is the effect of executing those 3 lines. Before we executed those 3 lines, these didn't even exist, let alone having values 1, 2, 3 in the memory. These variables themselves did not exist. Okay? So 2 things are happening in this one line. We are creating a variable for number 1, and we are then assigning whatever the input function is getting from the keyboard to number 1. Now, why do we have the int there? Well, when we type something into the keyboard, what are these? These are all characters, right? All characters. Some of them are alphabetic, A, B, C. Some of them are numeric, like 1, 2, 3. Some are neither, like punctuation symbols, comma, period. some are special characters like the asterisk, the @ sign. Whatever they are, they're not numbers. They are all characters, even when they represent a number. Like if I hit 5, that sends the character 5.
Not the number?
To the, not the number 5, okay? So, but we are, on the left-hand side, we're expecting numbers, because we're going to do some arithmetic, some math. We're going to add them up and average them. So we're expecting numbers. That's why we name these variables deliberately, number 1, number 2, number 3, rather than character 1, character 2, character 3. So the naming of the variables also indicate what we are expecting to be stored in that variable. Okay? So how do these characters, character 1, character 2, and character 3, get converted into number 1, number 2, number 3?
Passed as an integer.
The int function. So that's the task of the int function.
So be int
Yeah.
1.
Int parenthesis open parenthesis 1 close parenthesis character 1, that is, will convert that to number 1.
Oh.
So okay, so you see a lot's going on here in each line. And then in the next line we have another assignment statement. On the left hand side we have the variable average. We called it average. It's a no-brainer because we want to store the average value in it, right? And that's how it should be. Many programmers have the habit of just having a variable called a, or just a variable called x, or k. Well, to that person, when he or she is writing the program, it's clear what those variables are meant to store. But for somebody else reading the code,
It wouldn't make any
no
sense.
clue. Hey, worse still, the same person, a couple of months later, is scratching his head, trying to remember, what did I have this variable k for? Right? So, always makes good sense to have complete words, sometimes multiple words joined together to explain what this variable is for. Okay, so back to this line. So, when we have the assignment sign, we know that whatever comes out of the right hand side gets assigned to the variable on the left hand side. Now, in the right hand side, all sorts of different things can be there. We can have just a single variable, like y gets assigned the value x. And x may have some value in memory, like 10. In that case, y will end up getting the value 10. We may actually explicitly assign a number 10 to y. In that case, on the right hand side, we no longer have another variable, we just have the number 10. Or we can have anything. We could have not the number 10, but the string 10. Okay? It's up to us what we do. Or on the right hand side, we have a long expression which returns a value that gets assigned to y. Like here, it's neither a single variable like x, nor a single value like 1 or the string 10. Rather, it's an expression consisting of operators and operands that are combined and the value of the expression evaluated, and that single value is then assigned to the left hand side. Okay? So what would be that value? Number 1 has 1, number 2 has 2, 1 plus 2, 3, and then number 3 has 3, 3 plus 3, 6, divided by 3, 2. Should be 2. So the answer is 2. Okay, let me know if you have any questions. Number 3, an identifier can contain digits but cannot start with a digit. Now, what's an identifier? something that identifies something, of course,
Mhm.
right? But in our programming context,
Isn't it kind of like the word variable? Like it, I think. Maybe not.
yeah, it is the word.
Okay.
It is the word. Sometimes we have maybe 2 or 3 words combined together, but often just one word like number,
Mhm.
average. Yeah, that is the identifier. So the identifier,
Is being assigned to a quantity or?
no, it's just the name.
Okay.
It's just the name of the variable. Okay?
Oh.
So an identifier
The sheet over here is
is
The sheet over here is not hers.
I'm sorry.
the name.
The sheet over here is not hers.
Name of a variable.
What about the sheet?
There's a sheet over here. Who's-
Oh, it's
Nothing.
economics.
Oh, okay.
Nothing more, nothing less. It's just a name. But every programming language will tell you what's allowed as a name and what's not. And one example is that an identifier can contain digits but cannot start with a digit. So you can have an identifier with a digit. Can you name one?
Number 1.
Number 1. We just saw it.
Mhm.
Yeah.
Yep.
Okay. And but can we have number 1 is a valid identifier. It's legal. 1 number? No. It cannot start with a digit. Okay? It cannot start with a digit. It has to start with an alphabetic character. Okay, so that is
Alphabetic characters.
true. Number 4, what will be displayed by the following code? Okay.
3?
3? Okay, let's work through. We have the first statement is an assignment statement which assigns the value 1 to variable x. So x now has the value 1 in it. Alright?
Okay.
So with the execution of every line, things change, right? So now, after that, we have x sitting in 1. 1 sitting in x. So x now points to 1. And then we are, the second line, we're assigning another value to x, but the right hand side is an expression, a math expression, which has to be evaluated. So 2 times x would be now
Okay.
2 times 1, because x is now 1. So 2 times 1 is 2 plus 1, 3. And then if we print x, the value of x is now 3. Right? If we had put a print, let's say we insert a print statement between the first line and the second line, what would it print? It would print 1, because at that point it was 1, but at this point it is 3. So the value of variables keep changing as statements get executed. Okay? Yeah. So it's very dynamic. It's not like a painted picture, or you say, well, up there in that picture you have x equal to 1. Why is the same x being shown here as 3? Because things have happened to x in between. Okay. So the answer is D.
Oh, you had different variations of the code on the, I mean, different results.
Yeah.
Okay.
Yeah. So if we, instead of doing multiplying x by 2 and adding 1, if we did something else, then of course we would have a different value for x, and that would be printed by this print. Number 5, which of the following expressions will yield 0.5? Which one do you think?
A, B, and E.
A? There are more than one. Yeah, A of course. Yeah. A, B also. E? Yeah, A, B, E. Right. What would happen? Okay, so let me show the correct answers first. A, B, and E.
Oh, you choose all three of them, okay.
Yeah. Always look for the S. It says the following expressions.
Okay.
So that means it's hinting you that there are more than one correct answer.
So if only did one, did I get it wrong?
You should get part of that. You should get part credit for that.
What if we meant to
You'll get,
identify the one?
you'll get half. Hmm?
What now?
Okay.
Nothing.
Oh, okay.
What would you get? So this won't give you 0.5. What would this give you? C and D?
0.
Why 0?
Because it gives you the, I forgot what it's called.
Wait, what did they say?
It gives you only the integer part,
People are
and there is
upset
none.
because they didn't.
Right? 0.5 is the result. There is only the
There's
fractional
three
part,
answers that
0.5.
are correct.
Okay?
There's one.
And this is called integer division.
There's multiple
So the
choices.
result is
There's 3 of them are float division, 2 of
one
them are integer division.
integer
and
division,
the difference
2
between the two.
Uh-huh.
equals
So,
Gotcha. Thanks.
sure.
uh, 0.5. Okay? So the integer part is, well, if you can call it that, it's 0. It throws away the fractional part. This integer division, the 2 slashes, just gives you the what's before the decimal point. All right?
Yeah, the slash is the float division.
The double slash, the slash
Mhm.
is the integer division.
Oh, oh, okay.
Yeah.
Oops.
And the just single slash is the float division or real division.
Oh, okay. Yeah, I have to be careful you don't get those mixed up.
Yeah. What's the difference between this expression 1 over 2 and 1 over 2.0? Yeah. There is another significance. One has 2 in the numerator, the other one has 2.0.
He's saying,
As far as the actual value is concerned, it's the same, but inside the computer it's represented differently. Yeah. One is a real number or floating point number, as you call it. So float is short for floating point. Is a real number. Okay? What in math in general we call real number. So if you use a decimal point like 1.0 or 2.0, this is float 1, not integer 1. Okay.
Float 1.
The computer will actually use different number of bits to store 1.0 compared with just 1.
Oh, because there's a
So
there's a difference between the two.
Yeah, there is a difference in the way they are stored.
Okay.
Yeah.
So that's what it's.
So they're written the same way, it's just.
Yeah.
One has a .0 behind it.
Mm-hmm.
So 1 and 1.0, they're the same, but one's a float number, one's an inertia number.
All right, so that's our quiz. And now I didn't get to work out the home